Hi, everyone. Welcome to the live Infrastructure Water Roundtable. I hope everybody's having a great day. Thanks for joining us. Anybody that's joining us live here, feel free to make comments in the chat, ask us questions. If you don't like something, make a comment. We'll answer it, and we'll keep this show rolling. So we're going to start off with introductions. I start usually with Chuck Hansen. This time, we're going to start with Kyla Jacobson. Thank you for joining us.
All right. My name is Kyla Jacobson. I'm the retired Public Services Director from the city of Elgin, Illinois, which is a northwest Chicago suburb. I retired, 5 years ago. I have stayed active in the industry. I am now working for the American Water Works Association as a regional trainer. And I do a lot of training with small systems, specifically on water loss and leaks, etc. I left the northeastern Illinois area about a year and a half ago, and I live in the northwest Florida panhandle near Destin, Florida. So happy to be here.
Thanks, Kyla, for joining us. It's exciting. Sanjay, you're up next.
Hi, I'm Sanjay Pujari. This is my second appearance in this show. So, but I'm enjoying it. So my background is in technology, innovating in multiple different areas. I'm really focused on sustainability solutions, and water being one of the core things in our mandate as a company. So we are building solutions that help with preventing damages caused by water leaks and helping with water loss. So I think this is a pretty interesting topic today, so I'm looking forward to it.
Yeah, thanks, Sanjay. It's exciting. All right, Chuck Hansen, you're up next.
Hi, everybody. I'm Chuck Hansen, speaking from Sacramento, California, my office here at ElectroScan. Some of you may remember Hansen Software. I started that company with my father in 1983. So that would make me 40 years in the business. I think when I sold the company in 2007, we had something like 2 million work orders for fixing water leaks alone.
Wow.
So quite a bit of data background on it in the work order asset management area.
Nice.
2010, this guy named Ken Carey called me up and said, Chuck, how do you find leaks in water pipes? I go, well, you listen for them. It's just, but no, you really can't. You got high groundwater, you got noise. He says, is there some other technology to find it? So I founded ElectroScan in 2011 and here ever since. So it's been a fun ride these last 40 years plus. I mean, full disclosure, I helped my dad do a mainframe work order system for a sewer system in 1979. So technically I may be a few more years than that. So looking forward, and thanks for having me, everyone.
Well, I was 2 years old in 1979. So yeah, this is, man, I didn't know anything about water leaks, nothing like that. So, my name's Chad Smeltzer. I'm the host. My company is Big Procurement, where we help infrastructure companies connect with government entities. We do live events, we do media, marketing, roundtable discussions, things like that, as well as infrastructure management software. We build that. And it's been great to talk about these topics because we do not educate enough about water leaks, non-revenue water loss. I think there's a lot of webinars out there that a lot of people do, but I don't know how effective they are getting the message out. And we all have to be symbiotic and put out the same types of messages about like how to bring solutions to the table and make a difference here. So what would be one of the things, I guess what I'll start off with is like non-revenue water. I play from this side because I'm in the sewers and I'm learning more about water every day. You guys are more of the experts, hands-on. You've been in the trenches for a long time. Non-revenue water loss has been going on for so long. It's the deteriorating of pipes. And I'm just kind of giving you guys feedback of what I know. It's the pipe conditions. They deteriorate, they degrade, they start to break, they start to leak. We put Band-Aids. I call them Band-Aids. repair sleeves, things like that on the pipes to stop them from leaking, because it's expensive to replace a pipe segment, correct? And it turns out that I think there's 2.2 million feet of water main in the United States. And
maybe miles.
Do we know how many leaks are actually in the system with the technology, like leak listening devices and things like that? And I'll let Kyla, you can start first since you're new here. Give me a little bit of insight on, like, am I right? Am I wrong?
Well, first of all, you just said, what message do we need to make sure that we're sharing? And I mean, I remember when I started in the industry in like the mid 80s, we talked about water loss, a percentage of accountability. And, we still use that term, and we still talk about accountability in percentages. There's actually a little bit better way to look at this as a whole. And I'm going to plug the American Water Works Association, because they have they actually have a leak tool that you can use. And it's amazing, because because if you just say 15% water loss, 15% in the winter may actually be 22% in the summer, or excuse me, vice versa. It may be 15% in the summer, but in the winter, it's going to be artificially inflated because you're actually pumping less water. But the one message I think that we need to make sure that we get across is, I do a lot of training and sharing this information with operators, and unfortunately, they are not the decision makers. Mm-hmm. And getting them to understand that the non-revenue water loss is costing their utility significant amount of money, and then getting them to be able to convey that message back to the decision makers in their utilities. And, they all of a sudden, their eyes open, and they, the light bulb pops on, and they go, wow, we're spending all this time and effort making water, pumping water, treating water, and it's not gaining revenue for us out in the distribution system because we're losing it.
Right.
So, that wakes them up, but then they're like, I'm just an operator. So I've been reaching out to, supervisors, and I've actually done a lot of training for public officials to get them to understand what the recourse they have in order to try to recoup some of this and get to figure out their revenue, their non-revenue water. And I tell people all the time, count everything. If you're pumping it, count it. If you're flushing hydrants, count it. You may not be billing for it, but count it.
Yeah.
So you have the water that goes out, you have your revenue water, and you have your non-revenue water. You have apparent losses, you have real losses, and then you have unbilled authorized consumption. That's like, hydrant flushing or whatever, as long as and I tell people, meter it.
Yeah.
Whether you bill for it or not, that's a policy decision that your utility has to make. But at least you can meter it and you can know it, and then you can make more accurate decisions when it comes to water loss. I got lots more thoughts, but I'll let somebody else jump in for a moment.
No, it's good insight, and thank you so much for being a part of AWWA and educating and training operators, because that's super important. The World Bank estimates that non-revenue water costs utilities globally about $14 billion per year. Just to give you some insight, I did a little research. Sonia, you want to jump in and talk about non-revenue water loss?
Yeah, I think there's two elements to it, right? So one is when you're talking about non-revenue water loss, you're talking about infrastructure, all the water piping. If you just focus on the United States, the infrastructure and the age of all the piping. So all of these things play a big part. And again, looking at some of the data points out there, especially this one other data point from the American Society of Civil Engineers. I think they did some research, and we are losing about 6 billion gallons of treated water every day because of leaks, breaks, and other failures in the system. That's about 12 to 16% non-revenue water loss for all the utilities in the US itself. So that's a significant amount of loss. Now, this is not even taking into account what happens after the utility meters in the buildings and properties with all the leaks and infrastructure issues with piping, usage, user behavior, all of that. So there's a significant amount, and we don't even have our head wrapped around it because we don't meter enough. We don't monitor enough to get all of this information. So I think the first step is to know how big the problem is. I mean, we have some estimates, and then try to figure out how we can put mitigation in place to reduce this loss. I think that's my little 2 cents on this, but yeah,
It's
I'll let
good.
someone else.
I'm getting a little feedback somewhere. I'm not sure where that is, but thanks, Sanjay, for that. And Chuck, obviously, you've been doing this since I was 2 years old. So let's talk about non-revenue water loss.
Well, I would just have to say that the data was poor in the 80s. But as I look, 40 years, over the last 40 years, data has become incredibly more useful. I don't want to say it will get that. I'm not sure with all of the focus on AI. It used to be where most capital projects took age, pipe material, diameter, and really maybe one or two other attributes, and that's what replacement policies, plans would support.
Yeah.
And I think to Kayla's to Kyla's point, on metering, now that we're seeing so much more real-time data, having Internet of Things, IoT devices, sensors in the field, we almost can't get enough sensors. I mean, there are some utilities in the UK that are deploying 30 and 40,000 sensors throughout their network. Of course, their networks are so much larger, and getting that data, and I think even after looking at all of the data, all of the raw data in here, it really, you almost have to back up a step and say, well, look, it could very well be the classic 80-20. 80% of my leaks are coming from 20% of my pipes. Where are those? How can I focus on those?
Mm-hmm.
And we have a lot more focus on DMAs, these district metering areas, where we're separating kind of our high risk, our areas, and how do we focus on where we can get the biggest bang for our buck? How can we prioritize where we fix things? And to Sanjay's point, there's a lot of good behavior in the industry. There's a lot of bad behavior too. Because there are some agencies that I know personally that have 70 to 80% plastic pipe. And I asked them, well, how do you go about and do? And they do leak detections, if not once a year, once every 3 years for their entire systems. And I go, well, what do you use? He says, well, we use acoustic. And I go, interesting. Is it accurate? He says, no, we use acoustic. I go, well, why do you do that? He says, well, everybody knows that acoustic meters or acoustic listening devices, data loggers, correlators, so on, have a real tough time in plastic, at least identifying where they are. So that actually gives our agency the excuse to say, hey, we don't have any leaks. Must be from the customer side. We better raise rates.
Interesting.
These are old school, and these are dozens of old school, public works officials. That's how funding is. That's how they have substantiated those things. So I think as we get better data of where leaks are in the field, after we produce it to when we are getting that to the meter of the customer, we're getting a lot more automated meters so that we have that good forensic information there. Then we'll start locating, okay, where do we have to focus our efforts on? And then what are the technologies out there that can do that? Great.
Good points. My question is okay, we have hydrants every 500 feet, 400 feet, 600 feet, whatever it might be, 1,000 feet. That's almost a place where you could put some type of sensor, correct? Between hydrant to hydrant. Could you track leaks between hydrants? Just a curious question, but can anybody answer that one? I'm just curious.
Well, look,
you're muted.
I'll tell you, I've looked at the data. What you want to do is what happens when you have multiple leaks in a line, which you typically might have, whether it's a break, whether it's at a joint, whether it's multiple joints. You may hear something at a hydrant, but where is that in the pipe? Where are we going to be digging? I mean, the number one problem that we really don't like to talk about are dry holes. Hey, we think there's a leak. Let's start digging it up. And now we've got a 20-foot trench. And, we thought there was a leak. Let's keep digging. So, we need to know, are we replacing the whole line? Are we doing a point repair? Are we doing multiple point repairs?
Yeah.
How are we going to fix that? So, when you hear something and then you've got all of the other things that from a hearing basis, so much of the acoustic generation are false positives. We've got customer usage. We've got hammers. We've got repairs that are even giving us false positives. We have high groundwater. We may hear the small leak, which is a high-pitched sound. We might not hear the big leaks, which, hey, the pipe is already filling up. Water is surrounding that pipe. We're trying to hear the differential pressure between the inside of the pipe and the outside of the pipe. The outside of the pipe's already surrounded by water. That ain't going to work. So we have 100% whack-a-mole. So, we've got to make sure that we're using the right technology to pinpoint where these things are and have size known in something like gallons per minute, liters per second. We're just, we have a lot of things that are coming up. A lot of things that are tried. So those are that's where am I going to dig is what an operator wants to know.
Interesting.
And if it comes up a dry hole, you lose credibility for how you found that pretty quick. Yeah.
Kyla, you're up.
Yeah, I was going to say, you asked about the likelihood of putting, correlators on hydrants, and, can you do that? Yes. It would be relatively inexpensive, but yes, to Chuck's point, it's not 100% accurate, but it's more accurate than some talking head at a utility saying, it's not my problem. Let's just raise the rates because it's on the customer side.
That's a good point.
Yeah. So, and for water utilities, especially smaller or medium utilities, they don't have the financial capability to do, leak surveys on their systems as frequently as they should, and whether they use some type of sound listening device or electronic device or whatever, it costs money to do that.
Yeah.
And, I do a lot of work with small and medium systems, which, the bulk of the water is in these big, large systems, but we have thousands and thousands and thousands of small and medium systems. So I think that that's who we need to make sure that we're helping in the big picture. But, those correlators are kind of like an inexpensive way for them to be able to potentially identify a leak location. And yes, if you dig it and it's dry, bad on me. But the technology is getting better, whatever. Yeah. One thing I recommend to small and medium systems, especially when you stop and think about, I have this one system in Illinois that I like to use as my poster child because they're 42 square miles and they have approximately 400 miles of water main, but they only serve 393 people.
Wow.
So, yeah. So compared to Elgin, where I used to work, 120,000 people.
Yeah.
500 and some miles of water main and 39 square miles. So, geographically, they're bigger. They have, probably 2/3 or 3/4 of the water main that we have, but a fraction of the people to be able to pay for it. So if you've got a leak or if you're going to do leak surveys, there's so few people that are providing revenue to the system to be able to pay for those things.
Yeah.
So their cost of repairs, cost per foot of repair is redonkulously expensive because it's such a large system and they have such big water main. So a lot of times for small systems that are that far spread out, I recommend if they're going to do some type of leak location, whether it be electronic or correlators or whatever the system that they're using, maybe partner with some of their neighboring communities, because a lot of times the expense for that type of leak locating services is mobilization.
Mm-hmm.
And if they can, if they can contract with a company and be able to do, and that company can do 2 or 3 systems in the same geography, it makes it a little bit more economical for them to do it. And if they have locators, and that's another thing, if they had correlators that they can move around or have on hydrants or whatever, maybe they can share them with their neighbors and be able to at least get an idea. And for somebody like that doesn't have a lot of money to be able to have dry digs, they can do some correlator on their own and then maybe hire somebody to do, especially if it's a big leak, to get in there and figure out exactly where the leak is. Because a lot of times those correlators may tell you it's between here and here, but that may be 1,000 feet or whatever. So
yeah, that's interesting, Kyla. Don't they have leak devices, listening devices that you can pinpoint like right where the leak is now? I mean, you could just run the sonar thing right over to. I don't know. I just don't.
Well, I want to
go ahead, Sanjay.
Add a few comments here. So I've come across. So on the infrastructure side, there's been a lot of innovation, especially around this. We focus more in buildings, but I know of a technology that uses satellite data to be able to find all the water bodies throughout a specific area. And then what they do is they overlay the piping infrastructure, if the utility can provide it, on top of that mapping that they have for water bodies or concentration of water. And then if it overlaps the piping infrastructure, those are the areas that they highlight for investigation. So if there is a water leak and there's a lot of water accumulated in a particular area and there's a piping infrastructure going through that, then they go and check that out for leaks. So the company name is, I think, Utilis, I believe. They use satellite data to do this leak detection or pinpointing where they think a major problem might be. I've seen a demo of what they can do. We've been trying to collaborate with them because they've worked till the last mile, and from that point on into the building, they don't have visibility. So that's where we use pressure, ultrasonic flow, and temperature. These are the 3 sensors we use on our devices, and then we are able to look at pressure loss. So if there is a leak somewhere at a specific point or within a specific zone, if the pressure drops from the utility meter to the building, then there is a problem between the utility meter and where our meters are installed at the entry point of the building. And then we can try to find out if there is an issue there. So pressure, ultrasonic flow, we use all of that. And then on the infrastructure side, there are several other technologies, obviously the acoustic systems there, and then using satellite data to pinpoint water accumulation on the piping infrastructure. So, big picture, the problem is bigger than that. It's not just leak detection. I think trying to use machine learning, trying to use AI, so you're going to get information on leaks. We need to have asset management information to try and identify areas that are higher risk for failure. And then this can also help utility companies prioritize where the repair activity should happen to prevent the likelihood of a leak. Machine learning can also help with identifying customer behavior, usage patterns for water. If there's unauthorized water use, or if there's leaks happening on the customer side, that can be identified as well. And all of this data that you're collecting over time helps you with predictive modeling as well. So you can use this information to forecast some of the issues based based on all the learnings that you have from past data. It could be related to weather. It could be related to age of the system,
Yeah.
or even water demand. So I think all of these things play a bigger role. So using technology, machine learning, AI in the right way, data is available now. So it's just a matter of how you use that data to help utility companies manage their infrastructure better. I think that's where
I got something to go back. I always do this where I go back. So I don't know. I'm getting feedback again. Give me 1 second because I want to go back real quick and get a better perspective on this revenue loss. So obviously, when you got a water plant pumping millions, billions of gallons through a system, right? It's going to residential, commercial properties. It's going to the meters. Those meters are supposed to be monitoring how much usage is going to each property, basically what's happening, right?
correct.
You're talking, Sanjay, you're talking about AI machine learning, and you're talking about stuff that these meters, from what I've read, have 20 to maybe up to 40% inaccuracies in their readings on some of this stuff. You can't build AI machine learning off of that type of data.
No,
It's inaccurate, right? I mean, that's
Right.
the way it's going to be. And then you have all these leaks in the system that nobody really understands where they are located. We can't really pinpoint them just yet, but it sounds like the technology is almost getting there. And so that's encouraging. But it almost sounds like these communities will have to replace their meters for all these with new meters that actually accurately read.
So I think the problem here is it's the same analogy of using your old flip phone versus the iPhone, right? So the idea of using a phone in the old days is just for communication.
Yeah.
Today, a phone is a computer. I mean, it gives you everything. Your health information. It gives you data. You collect a lot of stuff, right? So that's what the water meter's main function is. Just in the old days was, hey, this is how much water went through it. Okay, generate a water bill.
Yeah.
Today, you need to add a lot more to that infrastructure to be able to provide meaningful data. So how are you going to do that without having that kind of information?
Good points. Sanjay, thank you. Kyla, go for it.
Yeah, I'm sitting here.
Waiting.
Yeah, you guys are all talking and I'm jotting notes. I'm like, okay, I got to talk about this.
Yeah,
So
go ahead.
meters. Let's talk about
Yes.
meters.
Sure.
There's two different meters that we're talking about when we're talking about water loss. We're talking about the production meter and the meters within a system.
Yeah.
And if that's not accurate, you're going to have all kinds of problems. And a lot of times, water utilities will do some type of calibration, but they're not actually doing a validation on the production meter. And that should be done fairly regularly in order to get the best, because that's the meter that's registering the largest amount of water. And if that's under registering, then it's going to throw all your other numbers off. So your production meter needs to be calibrated, validated, excuse me. Then, as Sanjay pointed out, the meters in the customers' homes, or industry, commercial properties, whatever. And they're various sizes depending on the need for the building. Local plumbing codes may say, hey, you've got 5 bathrooms and 2 laundry rooms and irrigation system and blah, 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 blah. You need a 2-inch service. Well, 2-inch service to a residential house. Well, there are some like that. I mean, there are some on the western side of Elgin that had 2-inch services because of the number of fixtures. But then small water use, if you have a traditional turbine water meter, may not pick up the low registers.
Mm-mm.
So that's one issue, So meter technology is actually getting better, but the meters need to be replaced on a regular basis. We had our residential meters changed like every 10 to 12 years. And then when we pull them out, we actually take them and put them on a test bench and do a sampling to determine how, just for our own edification, how they are registering. They always under register. They never over register. And, by keeping them the 10 to 12 year rate, we may only see 5 to 10% loss on the individual meters, but that adds up. And then you look at your commercial and industrial ones. If you have an 8-inch or 10-inch meter, hopefully you've got some kind of either compound meter or some ultrasonic meter that's going to pick up low flows. Because if you had a 10-inch meter in an industrial building, it's not going to pick up the water used for washing hands or flushing toilets, because it's just not enough water to make the meter turn. So anyway, the meters is a big portion of what we're talking about when we're talking about non-revenue water or accountability.
Right.
Because if your meters aren't accurate, then all the data you're creating from those meters isn't accurate. And then I'm going to keep going because I'm on a roll here. I'm thinking customer leaks. We've joked about that yeah, it's on the customer side. Let's raise the rates. One thing that I have found from talking to a lot of utilities around the U.S. is a lot of communities don't have procedures in place for what to do if the leak is on the customer side of things. In most places that I'm familiar with, the utility owns up to the Buffalo box. Now I live in a warm climate, so my meter is actually out at the road. So they own up to the meter, and then I own beyond that. So that's actually okay because it's getting metered. But where I used to live in Illinois, the meters were in the house. There may be 600 feet of water main on the customer side that beyond the Buffalo box that was their responsibility, but it's not being metered. So we actually had a policy in place whereby we would make notification that there's a leak on the customer side of the service, and they had to fix it. And we give them a date. And if they didn't respond to us or didn't fix it, we would then eventually shut off their water. We'd give them like a 30-day notice and a 60-day notice.
Yeah.
A lot of times all we were looking for is for them to come back and say, yes, we understand, and we're going to work on it financially. We're not capable of fixing it right now, blah, 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 blah. And then, we want them to fix it. But if they don't respond to us at all, then we're like, okay, we're going to shut your water off. But that's kind of the hammer we have. That's the only tool we have to get people to do the right thing. So, but I was really surprised to find out how many utilities don't have those type of policies in place.
Wow.
So,
well, let me just interject another hammer that we do have.
Lots of hammers. Let's go.
The Biden administration has given, I think, a gift to everybody in the water industry on customer side leakage, and that is through their the Biden infrastructure law, where we have to go out and replace all the lead pipes, and it's requiring every utility to go out and do a service line inventory of all their connections. And it's not just from the main to the meter. It is the main to the house. And this is all 50,000 water utilities. So I know of about a dozen large engineering firms shifting from their leak location to lead location and service line identification. And many are calling, hey, we've now got to do programs to actually go either inside the house, so we've got a basement entry, or we've got to go to the curb stop where the meter is. And guess what? We're finding a lot of leaking meters here, and now reporting that. So, and with the EPA deadline of October 16th of 2024, I mean, I've got 10 emails that I've gotten since I've been on this call just about this. So, so I think we've got a lot of gifts. I think M36, we're on our 4th edition for that. I don't sit on that committee. I'm on the M77 Condition Assessment Committee. But, I think we're doing a better job since I've seen the water equation of calculating the amount of water loss and kind of where that is. I think now it's really, let's go find them. And to Sanjay's point, I got to tell you, being in the business for 40 years and seeing all the vendor claims that have been out there, I am sick and tired of seeing, let's say, satellite companies that are calculating the number of leaks that they found through use of their technology. Maybe that plays to the ESG investors, and they like seeing that. But you don't find leaks from satellite. You find leaks when the boots go on the ground and start looking for them.
I think it's about predicting is what I was trying to get at. I've seen it. I haven't really used those technologies, but I think Utilis is being used extensively in LA by the Los Angeles utility, and that's where I saw them. But what they do is they predict and give you an idea of which areas to look for. That's what it is. They're not going to find it. I agree with you. But I think they give you a direction.
I think, because we've all been such old salts in this industry, this is an industry where we just have a lot of, if I can use the term, tribal knowledge, just a lot of gathered knowledge of what we've seen, what works and what doesn't work. And to see outrageous claims, I can't believe it. And you've got a lot of venture capital funding of folks that have never been in the industry, and we're seeing.
Have you looked at that technology at all? The ones that they're talking about using satellite data to look at wet spots and
we have several clients now trying to justify those. So those backroom discussions that you hear about, well, we can't find it. I would say water sniffing dogs are probably just a better bet than that. So, we want to really focus on things and actually find it, and confirm it. Okay, I found the leak. Now you go find it. That doesn't sound compelling to me for some reason, especially when the red dot is 100 feet on either side of the pipe.
Right. It's a huge challenge. I agree. Yeah.
And LA, the problem is that's a high groundwater area. So you got water all over the place. It's interesting.
So,
but we need more validation.
Chuck, thank you so much. Very enlightening, and Sanjay is very intriguing, because I'm just thinking, our technology is like going, rapidly, right? We're doing all this cool stuff with satellites. I think it's great, but we really have a big problem, and that's kind of what you guys are talking about, boots on the ground. Like the sensors, the devices, the meters are off. Like they're not giving us good data.
Way off. They're way off.
So that's a huge problem.
I wanted to add a couple of things.
Go ahead. Yeah.
So I think you talked about having the hammer, right? I think there are a couple of steps before that can be implemented before making use of the hammer, if you will. So there's a persuasive method to do this as well. If you're giving visibility, if there is visibility, if I'm using water in my home today and I get a utility bill, I have no visibility for what they're charging me, where I use my water, why is my water bill so high? And I might resist. I'm like, I think there's a problem. You guys increased my water bill. I don't know if there's a leak. There's no visibility, right? So if you have a technology that actually shows you how you've used your water, it gives you a forecast of what your water bill or your consumption is going to be at the end of the month based on consumption patterns using machine learning, then you are more involved. I'm going to get more involved. I'm going to see, hey, at what time, I used X amount of water for my shower. I'm using X amount of water for my landscape. Maybe I can reduce that by 20%. I want to budget my water bill to $100, whatever that is, right? So if I have that level of control, now I am financially responsible of how much water I'm going to use. There's some motivation for me. I don't have any of that control today with the way the utility meters are, right? I just get a bill at the end of the month. So if the billing is transparent, if I have visibility and I have control, if I'm able to reduce my overall water consumption, and I know where where the problem areas are, I'm going to be involved in this overall, endeavor that we have to reduce water footprint, find the leaks. I'm going to get involved in finding where the issues are as well. So that visibility doesn't exist today. And that's one of the areas we are working on with our sub-meters. I mean, those are the sub-meters that we do in buildings, is to provide that level of visibility based on machine learning. So how much what are your toilet consumption, how many flushes per day, all that stuff, right? So whatever is possible through technology, that should be made, that should be visible to everybody, to the utility company, to the end user. And I think that's one step. It's a small step, but at least it's a step. So right now, the existing utility meter does not have any of that built into them. And I think that's where we could, I mean, it is there, but it's not granular enough to tell you where you're using your water. I mean, I get a utility bill that shows my consumption, but it doesn't give me more than that, because weights and measures allows you to certify your meter for the low flow at 0.75 gallons a minute, right? You need ultrasonic meters that are much more granular to be able to pick a toilet flush or a low flow leak or any of those smaller signatures that are maybe less than a gallon per minute, right? So that's way less than a gallon per minute, maybe 0.04 or
Who?
So those are the
Sanjay,
things.
I got a question, Sanjay. Who's and Kyla? You're next. You're up next.
That's fine.
Who are the big players in the water meter business right now? Chuck, do you know anybody?
Oh, I mean,
Census, Itron, Neptune.
Yeah, Census, Itron, Neptune, Badger Meter. These are the big players on the utility side. And on the sub-metering side, there are a few of them as well. But I don't think there's any one of these sub-meters or meters that have shut-off system built into them. So if there is a leak, what do? You notify, but then can you automatically shut off the water and do a remediation, within the property, or notify someone or give them control to shut off the water. So those things,
vendors, those meter vendors, those large guys
are
probably have the biggest threats of their entire existence. I've only been, an Itron customer since I was doing, 1K of memory with Itron meters in Eastern Washington. There's a major threat happening to those 4 meter companies right now, and they should be deathly afraid of the new player in town. What has happened is it's so expensive to put in meters, an automated meter. It's millions to put in, right? But if you take a look at the cost, 80% of it really is data handling charges. And so the disruptor that's coming in, and it was very clear. I was in London at the World Water Tech. It's very clear. And I think this is going to totally upend the meter reading business within the next 5 to 10 years. And that is the fact that you have a company like Amazon that now is controlling, in some areas, 98 to 100% coverage of homes through their Alexa, Epic, Ring doorbell accounts. Those are mini webbed Wi-Fi networks. And what they're now in the position of with a couple of high-tech companies that are looking at this is being able to put low-cost sensors on standard meters and have that data not go through those meter reading companies to then charge exorbitant fees for their data. They now can use products like Amazon Sidewalk that will go up on a free network and deliver that information, and not just how much water was used, but water quality issues, a number of sensors, heats, acoustic if we wanted to actually get that information as well.
Wow.
So it is something that those vendors that you just listed are going to, that would cut 80% of their revenue, because again, putting the hardware together, that's a low cost option. We've all got it down. It's the data handling. And once you've got their meter, you are locked in to that vendor.
Mhm.
And I think that that's going to be a major change up in the water business. And this industry tends to move like I used to say icebergs melting, but dinosaurs. But I believe that economics will totally change the face of how we see what our customers are using.
Yeah.
And the cost of getting that information back to our enterprise systems back in the office that can be fed into intelligence systems. So, metering those things. And then by knowing what the customer is using, then we'll have that idea. Is it 80-20? Is it 20-80? Is it 50-50? What is that mix? Then what are we down to the DMAs? Because we can have these same devices. And it's amazing to hear the coverages that Amazon claims through Sidewalk. And it's no surprise that Amazon Water now is a big player in all of the conferences that are coming up. Patrick Kinney, you're welcome. So there are a number of things that I think will basically make these technologies we're talking about redundant.
Kyla, you're up next. Chuck, I'm going to go back to this whole Amazon thing because I can go. That's a whole thing. But Kyla, go ahead.
No, just kind of following up on these intelligence systems, and Chuck's totally right. It's all about data handling. But, I live in a new town. I don't live in a town. I live in a region. We have a regional utility, and we have smart meters. And I mean, where I was, we had smart meters, but we have lots of data. And Sanjay was totally right. If people start understanding their use and they start making, informed decisions about, hey, I don't want my water bill so high. I'm not going to water at 2:00 in my lawn at 2:00 in the afternoon when it's all evaporating because I'm not getting any benefit and I'm wasting water, getting people to understand that. But it's also getting them to understand. I mean, I've been in my house for a year and a half and my water bill is $63.22 every month. If my bill was $70, I'd probably have a stroke. Not that that's a lot more money, but there would be a change. So getting people to understand how those changes are going to affect, so that then maybe that's a leak. Heck, if my bill was $160, I would definitely know there's a problem. But getting people to be invested in, the trends and understanding that. And these are all great concepts for us to get our arms around, and the data handling and the technology to be able to gather the data. But at the bottom line, we need to get really super granular and get utilities to understand that there are losses in their system, and get them to understand that they need to be looking for them and they need to be making the corrections. I mean, we have all heard in the last probably 10 years, the water and wastewater industry, people don't pay a lot of attention to it because it's buried. I turn on my tap, water comes out, life is good. I don't think anything more about it. They don't think about the fact that, there's leaks and there's infrastructure that's been there maybe 80 years and it needs to be replaced. So just getting people to understand those concepts and understand, what apparent loss is, and look into leak management, and actually putting a cost to that leak, knowing what their customer retail unit charges for their water, and understanding how much it's costing them. For a small utility that may have a very small budget, we did an exercise and I showed them that it's costing them their total water budget is like $50,000. Their losses that they had was costing them almost $20,000. I mean, it's a third of their water bill, their total water budget. Yeah. So I think that, all these concepts are really great, but we need to, and a lot of these are focused at, large utilities that have more financial resources. But I think we need to be also being mindful of getting the utilities to accept that these problems are out there and how to go about finding them.
Yeah, you're talking about first episode we talked about the lead issue, right? And now we still have water loss never going away. It's been around for decades, centuries, maybe, I don't know, at least decades, right? So we're dealing with all these water issues, and we have no funding to fix these things or find some of these things and stuff like that. Sanjay, go ahead. You wanted to speak there.
Yeah, so I think the way I look at it is you have service providers, you have customers, right? So there's an ecosystem. There are stakeholders. So you have water, and then you have stakeholders, and all of their economies kind of depend on water. Utility company makes whatever their revenue from water. You have insurance companies. They pay for, if there is a water damage, they have to pay out claims. You have builders, property owners. They need to bill their tenants for sub-metering for water use. They want to make sure that buildings are not getting damaged and there's loss. And then you have homeowners. They don't want to have a leak and have property damage. So there's a financial element to all of these guys, and there are service providers and there are users. So I think at the end of the day, if you have the service providers kind of collaborate, I don't know if that's possible. Yeah. Utility companies and insurance companies kind of work together and say, look, we have a common problem. Leaks are causing revenue loss for utility companies. Leaks cause revenue loss for insurance companies. So if the insurance companies are providing some kind of a benefit for homeowners, property owners, builders to implement technology that can reduce that risk, and if the utility companies come up with rebates for property owners and builders to be able to implement these technologies at a lower cost, it's a win-win. And then you provide the right kind of information, which is transparent, so the insurance company knows systems are installed. The property owner gets some kind of a benefit for doing that. Utility companies provide a rebate for using the technology. In return, they see the right kind of information that they need to use for all of the things we talked about, maintenance, looking at, age of the system, looking at what kind of usage patterns are going on, what kind of fixtures are installed in the unit. So there's a lot of information that can be, generated from putting these types of technologies, and everybody benefits. So at the end of the day, it's not just a one thing fits all. It's a solution needs to involve all the different stakeholders, is what I feel. And it's possible today with the type of technology we have. Everybody feels empowered. If I have a mobile app that I can kind of check out my consumption and make sure my bill doesn't go over $63, like Kyle has said, and if I can bring it down to $50, why not? Because the utility company is looking for ways to increase their water bill, and they want to throw in a low flush toilet. They want to throw in efficient shower heads. So you feel great that you're using, your bill didn't go up, but actually your cost of water did go up. You just reduced your consumption. So I think those are the things that we need to think about.
So if we go take a step back, all right, we're talking about technology, we're talking about future stuff. Let's make it. We got like 7 minutes left. If we take it to like, what's the biggest priority? Is it fixing the mains that are leaking, or is it fixing the meters that are broken and not reading correctly? What do you think's the biggest priority? Chuck, go ahead.
I'm going to tell you the low-hanging fruit.
Okay.
Forget about looking for leaks in your pipe.
Okay.
Forget about it. You don't know which ones are the big ones and the small ones. Why don't we just focus on accepting the new pipes that we're putting in the ground? The requirement for a new pipe going in the ground is so little. There a recent study of new pipes that had leak detection tests. How do we test it? We pressurize the pipe, right? We see if there's any drop. If we just focused on making sure that the pipes we're putting in the ground don't leak, I think we'd be far ahead. So that's one low-hanging fruit. The second thing we've got to really know is we're just talking about water people here. 5 years ago, I got a TV tape from a sewer guy. He said, Chuck, look at this. He showed me a videotape before a pipe was rehabbed. And there was a gushing, clear stream of water through one of the services. Obviously, it was a water leak. They rehabbed the pipe. It was all pretty lined. They sent me the post-CIPP pipe, still gushing at the same time. That was 5 years after I saw it. And I tested that and I wanted a TV camera down. It was still leaking. So because the sewer people don't really like the water people, or the water people don't really like the sewer people in a lot of places, if we just sit down and talk about these things. I know as one city, they had a separate billing system for their sewer system and a separate billing system for their water system. Guess what? They had more customers on the sewer side than they did on the water side. And then they got the local garbage company in, and they had even more people they were billing because they're publicly traded. They knew. And so everybody's, from that point on, they compared the addresses, everybody's revenue went up 10%. There's low-hanging fruit out here. You can argue about a lot of things, but to really look at low-hanging water, get the teams together, water and sewer, start talking about it.
Love it. Good stuff. Kyla, you're up next, and then Sanjay, and then we got about 2 minutes each.
I think meters is another low-hanging fruit. It's expensive to replace meters, but meters fail and they under-register. And we are not getting the revenue for all the water that's entering the businesses and the homes. And I think that's, fixing the leaks is a big deal. And putting in pipe that doesn't leak to start with is a good thing. But I think if we do look at the meters and make sure that our production meter is validated and do all that stuff, I think that will go a long way to at least bring the attention as to what the real issue is.
Yeah. Go ahead, Sanjay. You're up next. Thanks, Kyla.
Yeah, I kind of agree with both Chuck and Kyla. I think today, in this day and age where access to information is easy, making sure you have the right technology in place to gather that information, gather accurate, meaningful information, which can be actionable, is important, right? So I think putting you have these old meters, you have old infrastructure, old technology, is not going to serve anybody. So I think we should look at diagnosing the problem accurately first before trying to putting the solution in place. So that's my 2 cents. I think that technology is available, use it.
Yeah. Go ahead, Kyla.
Can I just say one more thing?
Sure.
Again, a shameless plug for American Waterworks Association. If you go to their website, awwa.org, there is free water audit software that you can download. I think it was Chuck that mentioned earlier that the information that they ask you for input is a very eye-opening thing for some utilities, because they're like, oh gosh, I never even thought about getting data from that.
Right.
So, but the data, the software is free. You have to put your name and your email address just because they want to know who's downloading the software. I think it's Excel or an Access database. It's kind of fun to use. They've just made a major update about a year ago. And it's something that you can start now and then do it annually and build on the success of the input. And it's free. So yeah. I think it's a great start for people to at least to bring awareness to the issues.
Kyla, that's a great point and a great resource for people to go to. Thank you so much for sharing that. It looks like we solved all the problems for water today. There's no more issues with leaks and no more register issues with the meters, and all these good things are fixed today. No, we have a lot more stuff to talk about. We have a lot more discussions. I have a lot more questions. We're unfortunately out of time. So thank you guys, for being the guest, joining me as usual. This is our second event. It's been eye-opening, talking about all this cool stuff, tech and problems, and coming up with some solutions is our end goal, or at least consensus maybe. Everybody have a great week. Thank you for so much for joining me, and have a great day.
Thank you.
Thanks, Jeff.
Thank you.
Good to see you all.
All right. Bye-bye.
Bye-bye.